Alright, guys, I'm working on the 751A. I'm going to see if I can get it to work. I think basically we're looking at we need to adjust the VCO to see if we have a trimmer problem. Where's it at? I think C107. Okay, so it's the top one right there. Okay, so I'm going to some of this stuff out of my way, and I've been working on this radio a little bit off and on, but basically we got no receiver transmit on this band, and it works on every other band. Well, 12 meters also. So when you get the bottom off, I'm pretty sure it's down here. Yeah, down here I can see it. So, let me go get my screwdriver. I try to be really careful with this radio because the screws on it are actually in really good shape. Alright. Let me come back when I got the screws out so you don't have to watch me do all that. Alright, we got the cover off. I'm going to go try and look down into this thing and see. Yeah, so these are the plastic trimmers. I'm gonna say, oh, now the fucker's working. I mean, how am I supposed to fucking adjust the goddamn thing? You know, if it starts working. So we need to look over here and get an idea of what our VCO voltages are supposed to be. So I gotta find the test point. Alright, the lock voltage. Okay. We're concerned with 29 megahertz, which means it should be 6.5 volts, C107. Connect oscilloscope to R46 to measure the voltage. I don't want to fucking do that. EC power supply output voltage, oscilloscope 20 megahertz to 10 volts. Frequency counter, RF voltmeter. So the way they want to do it is reference frequency, connect an RF voltmeter to L13, which is not the same as a regular meter. Connect an oscilloscope to R46 and look for 3 volts. So they're just using an oscilloscope to look for the voltage. So after completing the adjustment, return J5 to original condition. What's J5? Where's J5? There's no mention of J5. Okay. No, what am I in? I'm on AM. Let me key this thing up. Okay. That's the interesting thing. I only get about 40 watts. Oh, that's an AM. That's fine. Yeah. Okay. That's normal. All right. Let's see if we can find out where. 6.5 volts at R46. Where's R46? J1. That's J1. We're not showing us R46. Interesting. Return J5. Where do they show J5? J5 is right here. J5 second low output level measurement location. Okay. Let me see if I can see it. It's at the corner. Okay. I don't actually see it. They show that IF cam. There's a big metal shield right there. Alright, that's interesting. It says W11 on the corner. J5. There's supposed to be a metal shield. I think this might be for the okay, so it's over here. Oh, I see it. Yeah, it's got a big old ferrite bead on it. Okay. Interesting. Yeah, there's a ferrite bead on it. They don't show that in the picture. So, we wanted to measure, connect to R46. Where is R46? They show the, it says the unit and the location. Okay, this shows R46 right here. Okay, so R46 is further over. Maybe they'll show it on the next page. No. They show the antenna over here. I'm not really sure what they mean by this. Okay. R46 right here. Aha. Okay. Alright. Let me get my meter out. I need to find my probes that have clips on them. Okay, I found one of them. I've got these clips. They go on here. Usually, they don't like this meter. These probes are too long. Okay, so I get the meter voltage. Here's R45, R44. Oh boy. They show it being right above the transistor next to something white. Oh, okay. Perfect. Okay. I got 3.205 volts on R46. I believe I'm supposed to have a lot more than that. Let's see. Oh, I'm not even on the right band. Okay, we don't have lock. Okay. I bumped the VFO. Alright. So we got 7.83 volts. That's too high. We do not want to do that. Alright. We're supposed to be 6.5 volts. And now I just bumped it. And it reads 5. But we can literally tap on the thing and it changes. Which means there's possibly some type of contamination going on in here. Right. I got 3.2. And I got 3.9, 5.6. Am I losing lock on this man? No. And it's now working on 10 meters. Let's go ahead and key it. Yep. So the problem is pretty intermittent, and let me try tapping on this. So one of the things I want to do is, I don't really have anything to lose at this point. I can get in here. It doesn't lose lock, interesting. Okay, lost lock. And what do I want to be at? I want to be at 6.5. I'm at 6.6, and we need to be on 29.99. Let me put it on. I think it wants to be 29.9. 29.9. $29.9, and we need to get it to though it's making noise, it's out of lock at 7.8. We're at 6.52, which is good enough. And what we need to do now is go check 12. We're at 3.3 at 12. And nothing else is going to matter. And so on 2805, we're at 5.3. So basically, let's take a look here and see what we're looking at again. All right. So, HPL lock voltage frequency display for the different bands. So we're looking at 21.99. I'm going to check that one just because. Okay. 21 what? 21.99. Okay. Oh, it takes a long time to get there, dude. Wait, no, it doesn't. Oh, it doesn't. Okay, so 20. $21, 4, 8. So it goes. Doesn't go that far. Let me put it in general coverage. $21.5 and $21.9. Okay, $21.99. I'm at 6.6. Okay, that's pretty good. So, because what this tells me is for that band, it should be at 6.5 as well as 14.99. Okay, 14.99. I'm at 6.28. That's close enough. Let's see. I'll show you guys what I'm doing. Okay, so I'm on 14. Let's see. I'm in general mode, which is what it says, lower sideband. Apparently, it needs to be in lower sideband. Okay, we'll see if that changes anything. No, it's still the same. I don't think it will change anything, but we'll just follow their rules here. And that's actually for frequency display 14.99 LSB mode. Okay, so 7.99. We're gonna go. Okay, 7.968, whatever. We're at 6.2. That's close enough. Okay, so 7, we've checked 7.9, we've checked 14, we've checked 21. And then the other ones, I mean, I don't have a problem with those. Let's see. And some of the other ones, the calibrator, the reference frequency, the PLL output, lock voltage. So lock voltage is for 7.99, 14, 21, 29, 8 megahertz, 15, 22, and yeah, they have different ones. So I think we're good. We'll take it out of general. We're at 5.3 on that band. We're at 3.3 for 12 meters. It doesn't really tell you. It covers such a large range, like the 80 meter, 160, and 40 are apparently all on the same thing. So, basically, this is a common problem with these, and it's probably going to continue to happen. I don't know if we can like get a good picture in here of where you guys can like see. These are plastic trimmers, and if you're lucky, you might get a radio where they've been replaced. There's wax down in here, okay? And the wax, we can't see it, but anyway, the wax can migrate and get into these. And so it causes all kinds of problems in this radio. This has got a pretty new battery. I want to test my battery voltage while I'm in here again, just for the hell of it. So, let me show you guys that. One thing that maybe, you know, some people would like to do, I have a PyX board for my other radio, but I don't like it, and it causes the RIT to do weird stuff. I'm trying to remember. So I think we're at 3.27, so we're fine. But if that battery does go dead, that board will actually be dead. You'll never be able to do anything with it unless you know somebody that can program it, because icom isn't going to do it for you anymore. So it's just limited to a few different icom radios at this time period. They decided to use a volatile RAM chip that needed to be constantly battery backed up. You can change the battery out, but you need to make sure you have 3 volts on it while you change it. So what some guys have done is they've piggybacked a couple of extra coin cells, or holders, or other things, or different battery holders for this thing. But I mean, I do own a PyX board, so if it did go, I have a PyX board. I have another radio that has a good battery in it. So the chances of both of my radios having this board crap out at the same time are pretty slim. And I basically really like these radios, but it's not like a daily driver kind of radio for me. But I wanted to have the PyX board just because, I mean, you may not be able to get one here in the future. When I ordered it, they didn't have very many left, and it said they didn't have any more for a while, and then I guess they got some more. But I don't know how long they're going to keep selling these boards for these radios. But literally, when it goes dead, the whole radio is toast, and it's just not a good design. So, like, if I was smart, actually, I would probably just get rid of these radios for as much money as they possibly could. And if I had to really have this radio, I would buy a 761, which is the same radio. You look at all this room in here, there's a ton of room in this radio. So there's actually a power supply that can go down in here, and it hooks up right over here. And you can see the connector here. So there's a plate that will go on the back of the radio, and basically you have all that room. So, but the 761 is basically a very similar radio, and it has a power supply and a tuner. It's more kind of on the lines of a 940. This radio is a really good radio, but I mean, you don't have the band stack registers, you don't have a bunch of stuff, and they could have added the extra digit on the frequency display, numerous other things. There was other radios that are older than this that have 2 digits after the megahertz, after the kilohertz. So they basically have 100 hertz resolution instead of the 10 hertz resolution. I always get that mixed up. Anyway, let's get it back together. Hopefully that's, maybe it was just off a little bit. Maybe it just needed to be, cycled around a little bit. We'll see. You never know. I may continuously keep doing it. I don't know. Can I get this thing to fit in here? I really don't want to. There we go. Okay. And it popped out again. Come on. Yeah, I gotta clear that screw right there, which is not gonna be super easy to do. There we go. They basically want you to pull both cases off. Yeah. Get that side. I like the actual like color of the paint on these two. It's kind of like a grayish green. This is the cleanest one I've ever seen, though. I mean, like the screws even just look really good. All right, so I think I got all the screws back into it, and now we can move it. I got code right here. Let's just take a look. Let's just make sure. Let's see if everything looks okay. I don't know where the microphone is to this radio. I gotta find. HM12 microphone. I don't know what this one would have came with, to be honest. Let's see here. Right. So if you can see the meter down there. 1 2 3 4 1 2 3 4. So 1 2, that's 50. 1 2 3 4 1 2 3 4, about 90. It doesn't do full output on 10 meters. I'm pretty sure all my other ones were like that too. 1 2 1 2 1 2 1 2 1 2. There's a little bit of a flicker in this thing. Hello. Now. Hello, 1 2 3 4, about 95 flickering. Okay. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2. Hello, 1 2 1 2 1 2. A little bit less there. Hello, 1 2 1 2 1 2, about 85. Hello, 1 2 1 2 1 2. Same thing. Hello, 1 2 1 2, maybe up a little bit. Hello, 1 2 1 2. And we lost it. Hello. So it still has a problem. Hello, 1 2 1 2 1 2 1 2. It was still transmitting. I was talking. I'm putting about 85. Maybe that's the 80, 90, 100. We're at 85, a little bit around that, and that was when it dropped out. I unkeyed. So I'm assuming it's going to keep doing it. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. Hello, hello. So the only solution to repairing this problem is going to be to replace those trimmers, and I have no idea where to get them. So icom doesn't have them anymore, as far as I understand, and they're also a pain in the ass to get to. So, but I did see it try and drop out, which means that the VCO voltage is moving around. The trimmers must be drifting, which also, if they start to drift while you're talking, you're going to hear warble. Let me put on another radio. I've got my FTDX over here. Let's go to 28. I'm going to go to 074 because that's just where I'm at on this particular radio. Why am I not seeing? Okay, 1, 2, 3, 4, we can see there's clearly a problem. Oh, 1, 2, 3, 4. Okay, I see. So when it was over there, well, no, this thing's doing something funky. Because it was over here, it didn't sound like that. It was sounding like something else. Okay, that's the mic gain. Hello, 1, 2, 3, 4. So it's not exactly on the same frequency as the other radio. Hello, 1, 2. One, two, 1, 2, 1, 2. So we heard the funny noise. Yeah, it was not working, and I can see it's flickering. Now I'm wondering, sometimes by doing that you can actually make it whack out. When I was smacking the bottom of the thing with the trimmer unit, it was doing something weird. Hello, 1, 2, 3, 4, and I feel like the frequency is moving around a little bit just because it seems like I can hear it changing. So it should not change from that. RIT shouldn't be on. Hello, 1, 2, 3, 4, 1, 2, 3, 4. So anyway, these radios are really cool. They got a really awesome receiver, but they've got a couple of problems. Lots of radios have lots of problems. But you have the volatile RAM, and you've got the problem with the trimmers. And that's pretty much really it with these. So if you buy a PyX board, you don't have to worry about that. So I have 2 of them. My other one I haven't had time to get around to, but it has loses lower sideband, so I think there's a problem in the BFO unit. So whenever I get time and I'm bored, I'll take a look at it. And it's a newer logo icom one also, but it has IF shift instead of PBT. So I don't know if the PBT is before or after they got sued. So I think Kenwood sued them for the terminology IF shift, and they had to change the circuit and change the name to passband tuning. It might have been the other way around. Either way, doesn't really matter. So thanks for watching. I don't know if this helps anybody, I don't know if this radio is going to behave or not.